we use low pass filter. Okay, we use low pass filter. Low pass filter. Okay, F. Okay, only the lower part of the signal will be allowed. Okay, only lower part of the signal will be allowed. So this is the result lah. There is the result. Other applications of DSP is communication, such as modulation and demodulation, for signal security, for data compression, for signal denoising, for audio processing, such as signal enhancement and equalization, for image processing, such as for enhancement, for classification, for segmentation, for data analysis and features extraction, to recognize structure on data, and also for in spectral analysis, or we call it as frequency analysis, which is the alternate approach to time domain analysis. Okay, for example, example in frequency spectral analysis, why it is important. Okay, if in time domain signal, the information that contain in the signal, we have the temporal or time, or time information, but we don't have enough information about the frequency. How do you know that the frequency of the signal? Is it 50 Hz? Is it 100 Hz? You can't get the information of the signal frequency, the fundamental frequency of the signal. Okay, so to find the fundamental frequency of the signal, you need the spectral analysis. So by using spectral analysis, Fourier transform, Fourier transform, then you will notice that the spectrum, okay, let's say it is look like this, okay, is at 50 Hz frequency magnitude. So in here we have the information about it gives information about the frequency. And then other applications of DSP is also for image processing, such as pattern recognition, robotics, image enhancement, okay, in telecommunication, for equalization, for echo cancellation, for video conferencing, for data communication. In biomedical, it is for patient monitoring, for ECG analysis, which is isyarat jantung, ya. For EEG brain mapping, EEG is brain signals, and then other applications are for consumer appliances, such as cellular mobile phones, digital TV, digital camera, PlayStation. So many applications of DSP. Currently, we are using every day in home, or also in our mobile phones. So this is the application of DSP. Application in speech processing, biomedical, ECG, EEG processing, EEG recognition, ECG recognition, EEG, what else? Fingerprint, EMG, EMG is for muscle. EMG is for muscle. ECG is for cardiac. EEG is for brain interface. Okay, speech. Speech is um to process speech translation, and then for music, image, video, conferencing, aerospace, in industry, in radar to detect aeroplane, ship, sonar is for sonar, and then oceanographic, communication, and power. Okay, power, for example, power quality signal, power quality signal, power signal. Advantages of the DSP system: it has guaranteed accuracy determined by the system that we propose, and then perfect reproducibility, because when we record digital, we can copy and repeat without degrading the signal quality. And then no drift in performance with temperature of age, and greater reliability, smaller size, lower power consumption due to advances in semiconductor technology, greater flexibility because digital, it can be programmed and reprogrammed without modification to the hardware. Superior performance because it can be performed which in analog it is impossible, such as adaptive filtering, channel coding, decoding. It only can be done in digital. And last but not least, the information is already in digital form, digital computer. So DSP is the only option to do computerized lah. If analog, we cannot do computerized for analog signal, yeah. If you want to save in computer, if you want to save in HDD or in cloud, it must be digital. The signal must be in digital. Okay, other advantages: easier implementation of adaptive algorithm. It is programmability. You can program it again and again without modify the hardware. And then the performance can perform function which not possible in analog signal. You can upgrade the performance um, by reprogram it without modify the hardware. But if in analog, you need to design it over again. Okay, but the disadvantages of DSP, of the digital, ADC and DAC is expensive. And if you want a higher resolution, and better higher sampling process, you want it a high performance, it will be more expensive. If low spec, it will not enough resolution for wideband DSP application. So, and then bandwidth limitation related to the processor cycle and algorithm complexity. So that's why DSP processor is expensive. If the spec is high, then the price will be higher. Okay. Let's say if you want to process signal in megahertz range, you need a proper IC that can process the signals. And then next is the complexity. Additional pre and post processing devices may be needed to to reduce the complexity. And then speed and cost. So in DSP, the speed is also the issue, not only the accuracy. We consider about the accuracy. We consider also about the speed, memory space. This is the things that we need to be considered lah when we we are when we do with working with the DSP system. Okay, most DSP are still not fast enough for wideband application. Bandwidth in the 100 megahertz range are still processed by analog means. So there are a lot of space to cover lah. For example, antenna design, submission, communication in signal communication yang related to um we call it 100 megahertz range ni, microwave signals. Okay, design time. Due to the shortage of knowledgeable DSP engineers and the necessary resources such as software package, DSP design can be time consuming. Okay, but this all the problems here are not really problem lah. This is more to macam human punya limitation macam tu. Okay. Okay, as the summary, DSP refers to processing of the signal by using digital technology, and it is better alternative to analog signal processing. So, so now you should know that digital signal processing, what is digital signal processing and the basic element in the system, and then you should know the reason why digital signal processing of analog signals is preferred, and also the requirement of ADC and DAC as interfaces between analog and digital domain. You should know three main important knowledge that you have learned in this chapter. Okay, next we will cover about the review of signals and system. Okay, see you in the next video. Assalamualaikum.